Gay-Lussac's and the combined gas law. So, Gay-Lussac's law. If the temperature of a gas is increased, then its pressure will increase if the volume stays constant. So temperature and pressure are proportional. An example would be a basketball. The pressure can be in any unit, they just have to be the same on both sides, and temperature once again needs to be in Kelvin. So aerosol cans carry labels warning not to incinerate or burn the cans or store them above a certain temperature. This problem will show why it is dangerous to dispose of aerosol cans in a fire. The gas in a used aerosol can is at a pressure of 103 kPa at 25 degrees Celsius. If the can is thrown onto a fire, what will the pressure be when the temperature reaches 928 degrees Celsius? P1 over T1 equals P2 over T2. So we know first pressure, 103. First temperature, 298.15. Equals, we're looking for our next pressure. So P2 divided by 298 plus 273.15. And we get 571.15. So now we need to cross multiply and divide. So 571.15 times 103. And we get 58,828.45 equals 298.15 P2. So we get divided by 298.15 both sides. And we should get 197.31 kPa. Okay, so now, a pressure cooker containing kale and some water starts at 298 Kelvin and 101 kPa. The cooker is heated and the pressure increases to 136 kPa. What is the final temperature inside the cooker? So we have P1 over T1 equals P2 over T2. So our first pressure here is 101 kPa, all over 298 Kelvin. Second pressure, 136 kPa, all over T2. So we have 101 T2 is equal to 298 times 136, which is 40,528. Divide both sides by 101. And we get 401.27 Kelvin. All right, so now last gas law we're going to talk about today is the combined gas law. So P1 times V1 over T1 equals P2 times V2 over T2. Once again, pressure and volume Can be the same, can be any unit, just they need to be the same on both sides of the equal sign, and temperature needs to be in Kelvin. So the volume of a gas-filled balloon is 30 liters at 313 Kelvin and 153 kPa pressure. What would the volume be at standard temperature and pressure? Okay, so we look here. We know standard temperature is 0 degrees Celsius. So that'll be 273.15. And 1 atm is standard pressure, but you could also use 101.325 kPa. So that's what we use since our other pressure is in kilopascals. So P1 times V1 over T1 equals P2 times V2 over T2. Our first pressure, 153, multiplied by 30 is all over 313. So pressure 2, we know 101.325. So what would the volume be? So that's our variable V2, and our temperature is 273.15. So 273.15 times 153 times 30. And we get, let's see, 1,253,758.5 is equal to 101.325 times 313, and we get 31,714.73 V2. So we need to divide both sides by 31,714.73. And you should get around 39.53 liters. And this concludes our video on Gay-Lussac and the combined gas law.